Hi guys, welcome to my YouTube channel. In this section, I want to talk about two things. First, the pH and the acidity scale, and then the oxidation state. Okay, so that's for today's discussion. We start with the pH. So about water, water is so ubiquitous that I can actually dissolve all of these colors in water. And sea salt is a mixture of different salts actually dissolved in water. And every time when we cook, we actually dissolve many things in water. When we do chemistry, we actually do solve many things in water. So water is the most potent solvent, and one of the reasons for that is water have a very high, actually the most largest dielectric constant. That's because water can actually self-ionize. That means H2O would actually a little bit, always on top, always it goes in the reverse direction, but a little bit of H plus and OH minus, the acid and the base. If there, so there is an equilibrium between the two. Like anytime you have any water solution, there must be a definite amount of these two ions. And the if you have water, it would be a little bit of this and a little bit of this. If you increase OH minus, so there is a delicate balance between them. If you have a lot of OH minuses, then it would be a very, very tiny portion of H plus. It means these two are a little, these amounts, and if you increase one, the other one decreases to actually balance off the ions. So the number of ions in water in a given sample of water should be equal to a definite number, and that's because of water soft dissociation. So if you increase OH minus, as we do in basic solutions, the H plus concentration becomes lower and lower, and if you do increase H plus, OH minus goes down. And that's why basic and acidic solutions are very potent, because they have in their solution we have more H plus than OH minus, so there is a net kind of charge in them. Okay, so that's how we actually actually talk about acid and bases. And we do know that for water, these two amounts are 10 to minus 7. It's a very small number, you might argue, but it's still important. So 10 to the minus 7 times 10 to the minus 7 is 10 to the minus 14. And this 10 to the minus 14 is always that. If you increase this, this would decrease. So that 10 to the minus 14 is always constant. Okay? Now, with this, I want to talk about the pH and POH. The concentration of H plus and the concentration of OH minus is shown in brackets like this. And there is also the rule for the pH. P essentially means minus log of anything, P of something. Okay? So if I say pH, it means minus log of H plus concentration. And if I say POH, it means minus log of OH minus concentration. Okay? And because the product of H plus and OH minus times together concentration is 10 to the minus 14, the pH plus POH, because these are logarithms now, is always 14. And that's the golden rule for me. So if I do have H plus concentration or OH minus, I could get pH or POH. And if I had either of those, I could actually compute the other based on this golden rule. There's also two more things to know about this, and that is, how do I compute the concentration of H plus or OH minus if I have the pH or POH? That would be 10 to the concentration to the minus pH So this would be the concentration of H plus. And you could do the exact same thing. Concentration of OH minus would be 10 to the power of minus POH. So that's the other two rules based on whether you provided with concentration of H plus, so you do minus log of it to compute pH, or you provided the pH, so you do 10 to the minus pH to compute this one. Let's do some of the numerical examples, and based on your calculators, you might need to do some tricks. I'm going to show you what to do with them. If you have a very simple calculator like this one that I have here, then you have to do a little bit more. Maybe if you have a scientific calculator that is more sophisticated, you might be able to easily do that. Let's do, before we waste more time on this, let's do some examples and then see how it works. The concentration of OH is 5.0 times 10 to the minus 8. I'm interested to know pH, okay? So the first thing is to do minus log of OH minus. That would be minus log of 5.0 times 10 to the minus 8. I'll just show you once on my calculator. On this, I have to do 10 to the minus 8 and then times 5 and then do log, okay? So instead of doing the minus, even if you have a scientific calculator, it's better to do log of that number first, and whatever the result was, you just change the sign to get the minus, okay? It makes your calculator understand better and you won't get messed up with the answer, okay? So for this, I do 10 to the minus, let me see if you could see that, yes, 10 to the power minus 8, and then close the parentheses. Also in my calculator, because it's very basic, you have to close the parentheses, times 5, it gives you this number. So that's the number, 10 to the minus 8, and then the pH, I just do the log of it and then do change the sign. So that's minus 7.3, okay? So that's this 7.3, but this is POH, okay? POH is 7.3, so I subtracted from 14 to get the pH, which is my desired one, and that's 6.70. That is my pH, okay? Let's do yet another example, and I won't do it on my calculator again. I just showed you once, but you must practice. Maybe on your calculators it would be easier, but anyway, you could do it on any calculator that you wish to. So that's the concentration of H plus is 4.10 to the minus 3. Again, you do for pH is minus log of 4 times 10 to the minus 3, and then it would be 2.40. That's what the pH would be if you do that. Let's do yet another example on this. What if, now let's do the example if we have the pH, okay? And I'll show you for the first example of this. If the pH is 3.5, what would be the concentration of H plus, okay? Now on my calculator, I have just to take care of the parentheses. So this is based on the formula 10 to the power of minus pH, so minus 3.5. And I do go here and say 10 to the power, for doing minus 3 over half, I have to do parentheses, open up parentheses, minus 3.5, close the, when I close the parentheses, it realizes that I'm doing this, and if I say equals, it gives me that. So then that becomes 3.16 10 to the minus 4. So I just did that for the first example. I would just want to do some more examples without showing you what I do on my calculator, but it would be the same thing that I just showed you. So it must be doable. Maybe on your calculators, you just And most of the scientific calculators, I would say, you still need the parentheses to make sure that the computer realize or the calculator realize that it's a negative number. So if the pH is 8.55, what would be the pH? Then the concentration of H plus would still be 10 to the minus 855, and that would be concentration of H plus is, if you do that, it would give you the scientific notation form of it, which is 2.82 times 10 to the minus 9. Okay, also let's do yet another example. If the concentration of H plus is 0.0001, what would be the pH? Well, there's for this, as you can see that if you have to put it in scientific notation, you could do the log of this, but it's kind of, you for this thing you don't even need to do something, it's just 1, so it's 1 times 10 to the minus 1, 2, 3, 4. To do the pH of this, if this number is a whole number, that would be just that number, the pH is 4. You don't need to do any calculation, okay? And also, if somebody told you the pH, for example, instead of 8.55 without any decimal is 8, the concentration of H plus would then be 10 to the minus 8. That's it. You don't have to calculate it. If it's this, because it has decimals, and for the scientific notation we always have 10 to the whole number, then we have to do it on the calculator and find out, okay, that is this, to take care of the decimal with this, okay? These cannot have decimal in the scientific notation, but if it's a whole number, and if it's easy thing like this, like the concentration of H plus is just 10 to the power of a whole number, that whole number would be your pH, okay? Even if this guy is 10 to the power of minus 4, 10 to the power of minus 4, 13, then the pH would be that, okay? But never somebody gives you a number like that. If they want to give you a number like that, they just gave you this, and then you have to do the minus log thing. But if it's a whole number, you don't need your calculator. Anyway, if you ever do your calculator, you will get the correct answer as well, but it's a waste of time. Let's also do the pOH of 8.5. The concentration of OH minus would be 10 to the minus 8.5, and that will give you 3.16 times 10 to the minus 9. And also, if you do the pH is going to be, so I just take 14 minus that, and it would be 5.5. I could do H plus then equals 10 to the minus 5.5, and it would be 3.16 times 10 to the minus 6. So there's a trick that I want to show you here. If the problem from the very beginning gave you this and ask for concentration of H plus, it's not necessary to do this step, because it's not going to help. It's going to take your time to actually calculate this, while the problem is only interested in this. To do that, you know that you need 10 to the minus pH, so you need the pH first, and that's simply 14 minus that, minus 8.5. that would give you the pH, and actually you would be getting you would plug it in 10 to the minus pH to get this directly. Okay, so just ponder up on the problem for a second to see if what is the most direct way to the answer, okay, instead of just doing rogue calculations. Okay, that's this. Now the pHs also, no one mentioned this. The pH, neutral pH is 0. The pH of less than this is oh my bad, neutral pH is 7. Less than this 6, 5, all the way to 0 is acidic, the most acidic, and 8, 9, all the way to 14 is basic. This is hugely basic, this is hugely acidic, and then you go to neutral as drinking water, and you see why pH plus pOH always be 14, because the range is just 14 in water, and that's due to the self-dissociation of water. So that's also what I wanted to mention about acidic solutions and basic solutions. Okay, if you want to characterize a solution as basic or acidic. Let's also go on a simple thing. I want to talk about the oxidation states real short, because we're going to need oxidation states when we want to do a redox balancing, and that would be my last series of videos on general chemistry. And to do that, we need to actually have a sense. So there are two things that are important: H, O, and halogens, being F, Cl, B, or I. Mostly following. Okay, halogens are most of the time, if they're combined with any element other than oxygen, and that's exception for FO, and I will give you that, halogens are always -1. Oxygen is always -2, and hydrogen is always +1. Now there are exceptions for these two, but if there are exceptions, the problem should give you that in a hint, that the oxidation state of H is not going to be +1 here, and oxidation of a state of O is not going to be -2 here. For X halogens, there are multiple times that you could see they're connected to the oxygen. So in those compounds like ClO4-, I actually computed based on the oxygen. Okay, and there's a rule for computing oxidation states. Okay, for elemental forms of atoms, even if they are these things, it would be 0. Let's imagine H2. Oxidation state is if you have x's, like assume that this is a number, x is a number, and number of them, 2x, is going to be equal to the charge. The charge is 0, so x becomes 0. Now any element, you take I2, that would be still this. You take F2 or O2, that would be still this. But if you have something like SO4 double minus, then S you don't know and you're going to compute. I take S plus, I have 4 oxygens and oxygen is this, so -8 equals the charge is -2, not 0. So the oxidation state of the ones that I know, there are 4 oxygens, 4 times -2 gives me a -8, and the charge of the whole molecule is -2. I could find the oxidation of S to be +6, because if you move that to the other side, it's just subtraction and addition, so it will change sign. Okay, it won't go in the denominator because it's addition and subtraction. So if you move this 8 to the other side, it would be, instead of -8, it would be +8, and you would get +6 for S. Also, if you have something as simple as this, it would be just S equals and the charge -2. So the oxidation state is the charge if you have one atom. Just like the simple case, if you have S8, okay, it would be 8 times S is 0, because the charge is 0, and then oxidation state of S is being 0. So that's how you do oxidation states. Let's just go to some examples real quick and find out if we could do it real fast. Let's do IO4-. Let's do MnO4 double minus. Let's do chromium I3. Let's do SO3. Let's do N3 minus, and also let's do N2H4. So for doing them, let me just talk about I and the number of oxygens. I plus, I have 4 oxygen, that is each is -2, so -8 equals -1. So I becomes, I just go on and use red. I becomes -8 becomes plus, and then it would be +7. Okay, on this one, and then Mn plus, again it's -8, but this time a -2 is my charge. So Mn is +6. This guy is chromium. There's no oxygen, so I is a halogen. I take it as -1. So -3 is 0 is the charge. So chromium becomes +3. SO3, again S, -6, because I have 3 oxygens, each being -2, equals to 0 again is the charge, and S becomes +6. N3 minus, I have 3 nitrogens, the charge is -1, so then this should be -3rd, -1/3. Okay, that's the charge for, that's the oxidation state for my nitrogen. Qn equals 4 hydrogen, Qn plus 4 hydrogens equals charge, which is 0, and then N, as you mentioned, becomes -4 divided by 2 minus 2, okay, each, because when 4 goes to that side it would be -4, and then once it's -4 it divided by 2 it would be -2. Okay, let's see if I have more time. I could do maybe a couple more examples here to make sure that you kind of know what to do here. Okay, let's do it real quick, and then that would be it for the oxidation states today. Okay, let's do it for HClO. Let's do it for CH3 Br, and also for PbO2. And I believe that would be it for today. So HClO, X plus H is 1. Let's just do Cl instead of X. Cl plus 1 minus 2 is 0. Okay, so then Cl becomes +1. Okay, if Cl is +1, you could see 2 plus 2, and 2 minus 2 will become 0. Carbon is carbon plus 3 minus 1 is also 0. Okay, so we realize that carbon should be -2. And Pb -4 is 0, so Pb should be +4. So that's the oxidation state, and I want to wrap the video up here.